guys, I'm here to talk to you today about irrational and rational numbers. The big one I put up here is irrational for right now because this is going to be something that you guys really need to know for when we get to Pythagorean theorem. Irrational numbers can be written only as decimals that do not terminate or repeat. Your most common one you know of is probably pi. It keeps going on forever and ever and never repeats. And the square root symbol, okay? Now, this might not make any sense to you right now, but once we do get into these questions, I'm going to show you some examples of irrational and rational numbers. It will make more sense once I show you some examples of what they look like, okay? Again, a repeating decimal may not appear to be repeat on a calculator because calculators show an infinite numbers of digits. I'll explain what that means here in a minute when I get to that slide, okay? Now, what you guys see here is I'm going to ask you if it's rational or irrational by just asking you two questions. If you see the pi symbol, or if you see a square root symbol. So on the first one here, do we see the pi symbol? No. Do we see the square root symbol? No. So it's rational. It's that simple. The next one, do we see the pi symbol? No. Do we see a square root symbol? No. So it's rational. Okay? Now, on this one, 5 ninths, do we see the pi symbol? No. Do we see the square root symbol? No. So it's rational. The last one, do we see the pi symbol? Yes, we do. So we said yes for one part. So this one is going to be irrational. Does that make sense? Okay? It's that simple, guys. It's that simple. You answer these two questions, pi symbol or square root symbol, go from there, you're done. Now, I want to go back to one just really quickly to make sure you guys understand something really quick. Do you see this one right here? This one, I usually tell my students in class, it will start to repeat. Even though it doesn't look like it right now. It will start to repeat eventually, and I always tell them that to make it easier on them, okay? Even though the dot, dot, dot says it's going on forever. I always tell them it repeats so we can say that it is rational, okay? Again, well, this one says irrational examples. I don't agree with that, all right? The reason being, what about 7/3? Do you see the pi symbol? No. Do you see the square root symbol? No. So it's rational. That one is rational. 7/3 is rational. All right. So I don't agree with my title I have for this one. I apologize. What about the square root of 5? Do you see the square root? Sorry, this is a square root symbol, guys. Yes, we do. You said yes, so it's irrational. Sorry, my handwriting is horrible this morning, but I apologize. All right. And the last one. You see the square root symbol? Yes, we do. So we said yes, so it's irrational. Simple. That easy. Don't make it hard and easy. So again, ask you two questions. Do you see the pi symbol? Yeah. No. Do you see the square root symbol? Yes. So it's irrational. Does that make sense? Next one. Do you see the square root symbol? Yes. So it's irrational. It's that simple. Next one. Do you see the square root symbol? No. Do you see the pi symbol? No. So we said no and no. So this one's rational. 0. Do you see the pi symbol? No. Oops, sorry, guys. No. Do you see the square root symbol? No. So this one's rational. Now, this one's a little bit different. Now, this is what I tell my 8th graders when I see them in the past. Try to simplify it first if you can. If you know what that means, I'm going to do the square root of 16 and 9. What's the square root of 16? It's 4. What's the square root of 9? It's 3. So you can simplify this one to 4 over 3. So on the new answer that we have, do you see the pi symbol? No. Do you see the square root symbol? No. So this one's rational. I write R for rational and IR for irrational. Pi symbol? No. Square root symbol? No. That means it's rational. It's that simple, guys. This one gets a lot of people, and I want to talk about this one. This one is not repeating. It's sort of like pi. It keeps going on forever and ever. Now, I try to make it as simple as I can when I teach you guys this. But this one is very, very similar to pi because it keeps on going on, but it changes a little bit by adding a 0 in between each 3. So if it's very similar to pi, what did we say pi was? Irrational, okay? Because it goes on forever and ever and does not repeat. That was a tough one. You see the square root symbol? Yes. So it's irrational. Can't simplify it either. See the square root symbol? Yes. It's irrational. See the square root symbol? Yes. Can we simplify it? No. So it's irrational. This one gets a lot of people. Remember your rules. Do you see the square root symbol? No. Do you see the pi symbol? No. So it's rational. I'm not going to walk you through these last couple. I'm going to go very quickly on these. I hope these help. I'm just doing you the basics. Let's see the rational or irrational. Now, be careful. The square root of 25, can you simplify that? Yes, you can, to 5. Do you see the pi symbol? No. Do you see the square root symbol? No, so it's rational. Do you see the pi symbol? No, but do you see the square root symbol? Yes. Can't simplify it. So that's irrational. Square root? No. Pi symbol? No. Rational. 2/3. Do you see the square root? Do you see the pi symbol? No and no. Pi symbol? No. Square root symbol? No. Rational. Square root of 36. Be careful on this one. Can you simplify? Yes, you can. To 6. Square root symbol? No. Pi symbol? No. Simple. I hope this is easy. Square root of 5. Do you see the pi symbol? No. Square root symbol? Yes. Irrational. Pi symbol? No. Square root symbol? No. And that's it, you guys. It's the basics that I'm giving you right now. So if you have any questions, feel free to ask me or Mr. Secatello or Miss Elkins or Miss Holness or Miss Rodriguez. Thank you guys and have a great day.